Hello, this is Paul Sun. Welcome to this deminar about Dapp and Kubernetes. In a nutshell, we are trying to figure out how to get a Dapp to fit in with the world of microservices. Here, the idea is to segment or partition a Dapp into different Kubernetes workloads and integrate them properly in the process. Let's see how this will fare or pan out as we move along. So the use case is about an eBay-styled marketplace driven by a Solidity smart contract running on a Ganache Ethereum blockchain. The Dapp presents a web-based front-end UI for sellers to place products to sell and buyers to list and purchase products. Pretty much the way a vendor machine is expected to function and operate. This is an outline of the interaction between different Dapp components inside and outside a Kubernetes cluster. The web app Kubernetes pod is used to compile and deploy the smart contract onto a Ganache Ethereum blockchain running in another pod within the cluster. And both pods are exposed as load balancer type Kubernetes services. On the user front, we will load app.js from the web app pod into the local browser to facilitate access to the Dapp front-end UI. And meanwhile, the NetMask wallet is installed as a browser extension to provide Web3 functionality to the front end. This will enable app.js to handle user requests by invoking remote calls on the deployed smart contract through JSON RPC. Now this can be viewed as a guideline to dividing the work between the decoupled Dapp pods. The web app pod also provides a truthful development environment for programmers to compile and deploy the smart contract. And on the Ganache pod, the Ethereum virtual machine is running together with the blockchain to serve the deployed smart contract. So now we are ready to move on to the hands-on lab. Let's refer to the README of this GitHub repository and walk through the steps. So this is the GitHub repository with the README files of the steps of deploying the Dapp pods and testing it out. And in this repository, basically, it contains two Kubernetes manifest YAML files. The Ganache deploy service YAML file is used to deploy the Ganache pod and the exposing service. And also similarly, the Marketfront deployed service YAML file is used to deploy the web app pod and also the exposing service. And here, the name of the web app pod is called Marketfront. The Kubernetes cluster is running on a VirtualBox VM, and this is a Ubuntu 20 platform. And the Kubernetes cluster is of the type is a kind Kubernetes cluster. And you can see the clusters consist of 3 nodes, 1 control plane and 2 worker nodes. So now let's move on to the first step of the hands-on lab. So first, we will deploy the Ganache blockchain pod and its associated service. So let's copy the kube control command. So you can see the Ganache pods and surface are both up and running. And you may also wonder, the Ganache pod comes up nearly instantly, immediately after we enter the kube control command. Usually that's not the case. The why the pod comes up so quickly is because the Docker image is already stored in the Kubernetes host. So if you download the Docker image for the first time from hub.docker, it may take you 3 to 4 minutes for the Docker image to be ready and for the containers to come up. And it's also worthwhile to note that for the Ganache service, it's already been assigned a cluster IP and an external IP. The cluster IP is for internal communication with other pods co-locating in the same cluster, in particular the web app pod. And the external IP, this one is actually a VIP managed by the Metal LB load balancer, and this is for access from clients or other parties outside the Kubernetes cluster. And so this address is mainly used by the other pod in the cluster, that is the web app, to connect to the Ganache blockchain. So another thing is that when the Ganache containers comes up, it will automatically run the blockchain, the Ganache blockchain process on a designated TCP port 8545. And in addition, we also instruct the process to output the activity log to these specific files. So let's check out this file to see if we've got what we would like to expect. I mean, from a running blockchain process on the pod. So let's capture the name of the Ganache pod, and then just execute the cat command directly into the pod. So we've got what we expect. This is the contents of the Ganache log from the blockchain process. First, the log lists the user accounts that come with the blockchain. So these are the public keys and private keys of the user account. And in addition, it also shows some important properties or details about the blockchain, about the Ganache blockchain. So here is the chain ID 1337, and also you also see that the process is also running with this endpoint. So what it means is that this 0.0.0 indicates that the process is listening on any IP address configured on the port. And the port number is 8545. So we've got what we expect from a running blockchain process within the Ganache port. So now we can move on to the second step of deploying the React.js web app port and its service in Kubernetes. As usual, we copy the kube control command. Yes, so both the port and the service are up and running in Kubernetes. Yeah, it is the same reason why the port comes up almost immediately after we enter the kube control command. Again, the Docker image has already been downloaded to the node and is stored in the node in advance. So if you happen to download this image from hub.docker, it will take 3 to 4 minutes for the Docker image to be ready and to be ready to give rise to the container, or for the container to be up and running from the Docker image. So after we deploy the web app Kubernetes workloads, there's an important step, or there's an important task we have to do. It is to hook up the front end to the Ganache blockchain service, because as you have seen in the architecture, the front end or the web app port and the Ganache blockchain port are two different containers, or the front end process and the Ganache blockchain process. They are running in different Kubernetes port. So we need to find a way to tell the web app port to connect to the target Ganache blockchain port or container. Yes. Let's capture the name of the front end port and also the IP address that the front end part or the web app port will use to connect to the blockchain. So as you can see here, the Ganache IP actually refer to this custom IP. So it means that this custom IP later will be used by the web app service to connect to the target blockchain. Before we make the change, so let's review what the default endpoint of the Ganache blockchain is for the web app. Yeah, and that piece of information is described in this truthful config.js. So as you can see, the configuration use this 0.0.0.0 NEIP destination to refer to the endpoint of the blockchain. So that means that by default, the truthful development environment of the web app used the local blockchain as the default target to deploy the compiled solidity contract, because 0.0.0 naturally it naturally refer to any local IP configured pod. So what we are going to do is to replace this value with the custom IP of the Ganache service. So this is what the next command will proceed to do. Yes, we will use the good old set tool to replace this bit with the custom IP of the Ganache pod. Yeah. And then check the result. Yep. So there you go. We have injected the custom IP of the Ganache blockchain pod to these files, so that we are now in a position to compile the Solidity marketplace contract and deploy it to the target blockchain that resides on this host. So let's use kubectl exec to run this command all the way from the Kubernetes host without entering the web app pod directly. We've done the compile, and then let's deploy it to the target blockchain. Great. So we have done our compilations and deployment. So now we are done with all the work that are confined to the Kubernetes clusters. And now we can turn our attention to the client side or to the user front. So our next step is to wire up the MetaMask wallet and Ganache. So in short, this step is to add Ganache blockchain on the Ganache port, on the Ganache Kubernetes port to the MetaMask wallet. So let's bring up the browser now. To assume we have already created a user account for user account on MetaMask to log in to the wallet. More precisely, a local MetaMask account so that we can log into the wallet and proceed with some MetaMask specific task. So first, so our first job is to let me open the. Yep, our first job is to add the Ganache port network. You know, the network contains the Ganache blockchain to the MetaMask wallet. So we just so let's add network. So we give it a name, specify the URL, the RPC URL, and then we will use the URL will be expressed in the form of disk. The reason why we use the localhost 8545 as the URL endpoint is that we have set up a number of port forwarding rules so that traffic directed to this endpoint will be redirected eventually to the load balancer VIP of the Ganache port. For details, you can refer to the prerequisite of the walkthrough. So so in short, all we will see is that the host port 8545, there's the local host 8545, will be first traffic to this endpoint will be first redirected to the guest VM at port 8545. The guest VM actually is the host of the Kubernetes cluster. Yep, so it is this one, and then using the SSH tunneling capability of PuTTY, we can redirect this source 8545. Here, source 8545 actually refer to the traffic received at this end, and then it will be, and then the traffic will be eventually redirected to the to this destination. And as you recall, this 172.18.0.10 actually is the VIP of the large service. Yes, this is the one that is named for the large blockchain traffic. So let's so we entered this one. What was 8545? Then the chain is 1B37. Yeah. So we can so we press save, and that will add the network to the MetaMask, and then it goes without saying that we will also do the step of switching to the Ganache Kubernetes network. Yep. So now we have entered our Ganache network. Yeah, I think that, sorry for that. There's a typo. It should be 8. It should be Kate 8S, not Kate 83. But anyway, we leave it as it is, as long as we are aware that this one refer to the Ganache port network that we are working to right now. So we have already added the network to the MetaMask wallet. So that means we have finished our step of wiring up the MetaMask wallet and Ganache. So so now we come to the last step is test it out through the front end. So basically we open the URL to the front end, and as you can see, the URL also bear the local host as the endpoint. It also we have also created, as in the case of the Ganache URL, that we have created a series of port forwarding rules, and that will eventually redirect traffic for this particular endpoint to the traffic for the microservices of the web app. So the local, you can refer to the prerequisite for the details. Yeah. So but anyway, it just this redirection path. Yeah. 300 host port, local host 3000 to the VM host 3000, and then from the VM host 3000, that is the source L3000, finally to the destination, to the VIP, to the web app VIP. So we just, so let's go to the local host 3000. Yes, and there you are. We are now comes to the basic, or to the skeleton of the Dapp front end. So before we fill in the field for adding the product, or testing the function of listing and buying product, we need to import some of the accounts that comes with the Ganache blockchain. And after that, we will use those accounts as a seller or as a buyer to interact with the DApp or with the marketplace functions of the DApp. So now we can import the buyer accounts and the seller accounts to the MetaMask wallet. So now we import the account. So first of all, let's recap the Ganache lock that is available from the Ganache blockchain port. And as you may recall, that log file also contains a list of accounts that are available or that are predefined or pre-created on the blockchain. Yeah, so this is the Ganache log, and we move up to the user account session. Yep. So our intention is to import account index 1 or account index 2 to the MetaMask wallet, and account index 1 will become or will be designated the role of a seller, and account index 2 will be designated the role of a buyer. So let's copy the private keys. You also show that this is a brand new user account without any experience of doing the Ethereum transaction. So you have the original amount of 1,000 ETH units in this account. Now we rename it to a meaningful title or name, and we give it the name as a seller, the name of a seller. We name it seller. And then we also import another account from the Ganache blockchain as the buyer. So this is this account. Again, you also have an initial amount of 1,000 ETH units associated with the account, and we give it a meaningful name, and that is buyer. Yes. So we can check that we can check the public keys of the seller and the public key of the buyer um, are actually corresponding to the one to be found here. So the seller should be the public key of the seller should be shown on the MetaMask wallet. So it is with this one 5B9D SC. Yep, this is this 5B9 something that correspond to the 5B9, the full public keys listed in the log. And meanwhile, for the buyer, B66 something also correspond to this account at index number 2 on the Ganache block, as shown in the Ganache blockchain log. So we have imported these two accounts properly to MetaMask. Now it's time for us to take on the road of the seller to add product to the marketplace. But before that, we need to make sure that the seller is actually connected to the front end. So so we will connect the seller to the front end now. So every activities that occur to this front end will be associated with this seller account. So now we can add the product to the marketplace. So add USB flash drive. It's 2. Then we install 15. Yep. And then we add product. Yep. We receive this notification. Oh no, I think we need to reconnect. We need to make sure we are actually no. Yeah, I think this is also an indicator of the active user account that is using the marketplace. Yeah, we need to make sure that it is the seller that is using the marketplace front end at this moment. Yeah, it's connected. Yeah, I think we need to refresh. Yeah, so it's 5B907. Let's double check 5B9D7. Okay, yep. I think that we are ready to go. Or the seller is ready to add product through this front end. So as usual is the USB flash drive and it's 2 ETH, 2 ETH, and it's 15. Yeah, we add the product. Yep, we can go. Yep, this is the amount of gas the seller have to pay for putting the product onto the marketplace. Yep. So we confirm the transaction. We go ahead. Yep. So the transaction is confirmed. Can let's refresh the front end to see if the product is listed underneath. Yep. We have the product listed underneath, and you have the stock, the price, and most importantly, the owner is the seller of the product. Yeah. So here, so now we can add another stock. So let's add an Ethernet cable. This is the one 20. The notification, and we confirm the transaction. Let's go ahead. We press to pay. Yeah. So yeah, we see another product that another product and its stock that have been placed to sell by the same owner. So we add a final product for this seller. Yeah, it's this category album 8. Right. Yep. So we can say we come to the stage that the seller is content with all the products he or she have placed in the market space to sell. So he's now just prefer to wait for any order to purchase from the products that he placed in marketplace. So now returns to the activities of buying product. But first of all, we have to switch to the buyer, so that any user activities from now on, any user activities with this front end will be associated with the buyer. So let's get to the buyer. And then we connect. Yep, we have connected the buyer to this front end. But before that, we need to refresh the web page. So now, as you can see from the account indicator, so it's 366C6 to see if it corresponds to the buyer. Yep, correspond to user number 2 on the Ganache log. That's exactly what we mean for the buyer account. Yep, so we are now ready to choose and buy the product. Let's say we buy something like 15, we buy 6. Yeah, one thing is that you can check. Let's check the amount of ETH units that are currently held by the buyers. That you can see is 1,000. Yep. So now we used we use those available ETH units to buy this USB flash drive. Yeah. So this already indicate the transaction amount is 12 ETH units. So we just confirm the transaction is okay. And we can go ahead with that. Yeah, confirm, and then we. Yes, one thing is that you notice that the stock has decreased from the original 15 to 9 because 6 of the items have been sold to this buyer. And another thing is that we can also check the ETH units currently held by the buyers. Yeah, so the 1,000 at the beginning, and now we have something like 988. And at the same time, I think we have a corresponding increase in the amount of ETH units held by the seller. So this is one purchase. Let's try out purchase for the other 2 items. Yep, let's get to buy the Jenny albums 8 and buy something like 3. So it means that the transaction amount is expected to be 15, and the number of ETH units being held by the buyers will be 15 less than now. Yeah, the transaction amount is 15. So firm. Yeah. We refresh the. Yeah, so you can see first it's 8, and then it decreases from 8 to 5. You can see the amount of ETH units being held by the buyer. Yep, so you can see it's now the amount becomes 972, and you also list the buying transaction that the account has done. So this is first minus 12 and then minus 15 is and you notice the corresponding increase in the seller. So finally, we go to we turn our attention to the Ethernet cable. So it's 20 by 12. So that should come down to drop to 8 after the purchase if the purchase is successful, and the amount of transaction should be 12. Yeah, so the total amount of transaction is 12, and we confirm the transaction is okay. And then we refresh. Yeah, so it becomes 8. Yeah, so the stock number of the individual product items actually agree with the transaction we have made so far on this front end. And finally, we check the amount of ETH being held by the user accounts, whether it's a seller or the buyers. Yep, so you can see the buyers has done 3 transactions. So this is the total amount of ETH he or she spent in those transactions. It's 27. 27 is 39. Yep. So the total amount of ETH units that he or she spent in the 3 transactions is 39 ETH. So yeah, this is nearly 961. Yeah, so they agree. So the total amount of the ETH values is agree with the amount that are spent in the transaction. And we come to the seller. Yeah, the seller also have a corresponding increase in the number of ETH units that he or she is holding. So it's also the 39. Yep. So there you have it. We have gone through a hands-on lab of deploying Dapp components onto a Kubernetes cluster, and we also test out the Kubernetes-driven Dapp and found that we get the expected result. So I hope you'd find this deminar useful. And should you have any questions or comment, please drop me an email or message me through LinkedIn. So thank you for joining this seminar, and hope to catch up with you very soon. Okay, thank you. Bye-bye.